Examples 1.1 to 1.6 explore the New York Times graph. Each row represents a community. The tag cloud displays the vertex labels within a community. For example, this community contains vertices such as Middle East and North Africa unrest 2010 and after, and Libya. This community contains vertices such as nuclear energy and Fukushima Daiichi nuclear power plant at Japan. The communities are sorted by their sizes in descending order from top to bottom. Smaller communities are accessed using the scrolling bar. The vertex plots show the expanding neighborhoods of the communities. The vertex plots in this column display member vertices of the communities. It seems that the 12 communities identified by the Edge cluster algorithm have similar sizes. The vertex plots in this column display the step 2 neighborhoods of the communities. It seems that all the 12 communities can reach most vertices in the graph in 2 steps. Communities identified by the MCL algorithm have more varying sizes and connectivity. For example, this is a community whose sizes are much larger than the other communities. This is a community which has a poor connectivity to the rest of the graph. This community has vertices such as nuclear energy and Fukushima Daiichi nuclear power plant at Japan. A user wants to know how this community is related to other communities. To do so, she sets the selection status to New and clicks the D1 plot of this community. Now all vertices connecting to this community are selected and highlighted. She clicks the Sort Cluster button. The communities are sorted by the number of selected vertices they contain in descending order. This is a closely related community. She decides to merge this community with the nuclear energy community later. This is another relevant community with vertices such as France, Russia, and Germany. How is this community related to the nuclear community? She wants to know which vertices are connecting these two communities. She sets the selection status to intersect and clicks the D1 plot of the France community. Now only vertices connecting to both communities are selected. They are the bridging vertices. The user wants to focus on the bridging vertices in these two communities. She sets the selection status to Remove and clicks the member plots of other communities to unselected vertices in them. The user clicks the View Edge button to examine edges among the selected vertices. From this window, she finds interesting articles such as one titled, "Japan's Nuclear Crisis Strikes Fear in Europe." The user is interested in terrorism events reported in the New York Times corpus. When browsing the communities, she finds a community with the vertex terrorism. She wants to examine vertices connecting to terrorism within and outside of this community. To do so, she selects terrorism and creates a U-group. She clicks the D1 plot of this U-group. All vertices connecting to terrorism are selected. She sorts the communities by the number of selected vertices they contain. It is not surprising that some vertices in other communities are connected to terrorism. Why was YouTube.com related to terrorism? She decides to examine the common neighbors of these two vertices. She creates a U-group for the vertex YouTube.com. She intersects the D1 plots of the two U-groups she created. Now the common neighbors of terrorism and YouTube.com are selected. To examine the selected vertices easier, she creates another U-group to hold the selected vertices. The vertex Anwar al-Awlaki triggers her interest. She selects this vertex, terrorism, and YouTube.com. She examines the edges among these three vertices. The news article, "Radical Cleric Still Speaks on YouTube," gives her the answer why these vertices are related. In this example, a progressive visual exploration has been conducted. Intermediate results are recorded in the U-groups, which can be kept for future use or be removed if they are trivial. To merge the nuclear energy community, and the Japan Earthquake and Tsunami 2011 community. The user selects vertices in the nuclear energy community, sets the selection status to add, and then adds the vertices in the Japan Earthquake community into the selection set. Now she can create a U-group that merges these two communities. The user wants to identify vertices in the person category that are related to terrorism. To do so, she creates a U-group for terrorism. She selects the neighbors of terrorism by clicking the D1 plot of this U-group. Then she sets the selection status to intersect and clicks the PER vertex plot. Now only vertices in the person category connecting to terrorism are selected. She sorts the communities to examine the selected vertices easier. The user wants to investigate how the Japan earthquake was reported by the New York Times. To do so, she selects the temporal vertex plots one by one and examines how vertices are selected in the U-group she created in example 1.5. Examples 2.1 to 2.4 explore the InfoVis co-author network. Move the scrolling bar to browse communities identified in this graph. The user is curious on which communities have no collaborations with the community with Ben Schneiderman. She selects its neighbors by clicking its D1 plot and sorts the communities by the number of selected vertices they contain. She drags the scrolling bar to the bottom and finds 3 communities containing no selected vertices. They are communities disconnected to the biggest community. The user wonders if any persons can bridge the Ben Schneiderman community and the Helen Purchase community. She intersects the D1 plots of these 2 communities. Three vertices are selected, and they are the bridging persons. The user wants to know the collaboration between John T. Stasko and the other communities. She creates a U-group for John. She clicks its D1 plots. All authors collaborating with John are selected. She sorts the communities by the number of selected vertices they contain. She immediately finds out that there are 6 other communities that John collaborates with.